WEKA is on the front lines of a lot of these things having to do with agents. If anyone's been involved in building enterprise agents, you'll probably hear about the memory wall. If you're using a lot of tokens and the context that's necessary to keep those tokens and memory from chat to chat or for instance to instance. And so they have been working on solving some of those things. So we're going to be hearing from Shimon Ben David, the CTO, who can help sum up some of these things on the infrastructure side.
Thank you.
So yeah, thank you for supporting this event, Shimon. And WEKA has arrived with a product right at the right time. And so you just closed with that piece around the unit economics. One of the other things that are broken right now with agents is this statefulness, right? Because of the context needs to be carried from call to call. And that has just not been there. And so Google just has announced this interactions API. You're going to see this statefulness as you have that ability to save that context. We've seen longer context windows. So the cost, as I understand it, the cost of these tokens is going down, right? We keep hearing about the cost, but it turns out that the token usage is actually going faster than the cost of tokens going down. Because of things like statefulness. So
That's a good problem to have, right? People are using AI more and more.
yeah, it's definitely a good problem. In going to that, where we were talking about is the enterprises are struggling with just managing the model zoo, right? You know, I mean, these hundreds of models that you just heard Amjad talking about, right? Where you're turning to the models that work for specific cases. So why is the model repository becoming such a choke point for inference?
Yeah, so I think those of and it seems like we have a very technical audience, so that's great. I think when we're looking at inference environment, there's a big difference between environments in pre-production, in benchmarks, and those of us that are taking inference environment to production grade, running multiple models. There is no, and we heard Amjad actually also saying it, and Mike also mentioned it. There's no one or two models that I run as an organization. Definitely when I'm running an agent, multiple agents, agent swarms, which we're starting to see more and more, all of these models needs to be activated, deactivated in a fast fashion.
Right.
And sometimes there's this, we're all talking about high-level AI use cases, but eventually there's physics behind it. These models contain a certain capacity that needs to be loaded into GPU memory or TPU's memory, loaded, activated. We see customers with hundreds of terabytes or petabytes of model repositories, and these models actually needs to be activated in a fast fashion because eventually in inferencing, latency is king, right? If I have a user and if I reply within 1 second, and that's my SLA, or it takes 10 seconds, maybe now they'll go to the next model, right? So the ability to move between models, activate models on my inference environment at scale is very challenging. Now, the challenge is that my physical components, my GPU, TPU servers, don't have that capacity to accommodate for all of my models. And then suddenly, what do I do? Do I now, for example, I'll give a customer that we worked with, Cohere, a large foundational model provider, running on multiple cloud environments. And one of their challenges was they have a dynamic inference environment, hundreds of GPU servers, thousands of GPUs. Obviously they have multiple models, Command R and more, but they had variations per customer, per sub-customers that they were using. And they had their environment that could accommodate for a certain amount of prompts at a certain SLA. And eventually, when they got a burst of more inference requests of prompts, they needed to scale out in an elastic way, right? This is the cloud. They needed to scale out and scale back in an efficient way. It took them around 5 to 15 minutes to get a new instance with model loaded, up and running, ready to serve a peak of inference requests. That's a long time, right?
Yeah.
We were able to decrease it, right? But you need that elasticity. You need to be able to accommodate for multiple models. Additionally, what we're also seeing is that it's not only that because the inferencing is growing, but there's still a lot of training environments, right? So between training environments and inferencing environments, how do you manage your GPU utilization in an efficient way? How do you utilize both environments concurrently to make the best effort out of it?
Yep. Yeah. This is really interesting. So as you hit the statefulness and you're hitting this memory wall, what's stopping these customers? I mean, you mentioned Cohere, but generally these enterprise companies do have, maybe a multi-cloud environment. Why don't they just go to the cloud and just maybe load up on GPUs for that inference?
Some of them wish that they do. There's some problems that you cannot throw enough money to solve.
Yeah.
GPU are a scarce resource. And when we're, again, being a deep tech company, when we're looking at the infrastructure of inferencing is not a GPU cycles challenge. It's mostly a GPU memory problem. If you're looking at the notion of inferencing, you have this construct that are called KV cache, which is essentially the memory, the context windows of the models that you're using. And in production grade environments, again, you're trying to spread the load across hundreds or thousands of GPUs. And to answer all of these massive prompts, the challenge is actually your context window, your GPU memory, which is saved on the HBM of the GPU memory, right? And imagine a co-development environment like Rapid mentioned. You're throwing tons of codes eventually translate to capacity. I'll give an example. Depending on the model and the amount of layers, right? 100,000 tokens can be 40 gigabytes of memory. That's out of your 80 gigabyte or 140 gigabyte of HBM, right? So if I'm throwing 2, 3, 4 books that are 100,000 tokens, that's it. I ran out of my KV cache capacity on my HBM. So suddenly, what the inference environment needs to do, it needs to drop data. So I pre-calculate, I pre-fill, I create that KV cache, and I start decoding on it, setting up tokens. But as I generate more data, I now need to drop my previous data. So I end up eventually, when I need it again, I need to recalculate it. So we constantly see GPUs in inference environments that are recalculating things that they already did. So you're pre-filling, decoding, pre-filling again, the same thing. More than that, we actually see large model providers, and I think if you look at the pricing, it's very apparent. Anthropic, OpenAI, and others, they're teaching you how to generate prompts that are hitting your same GPU on the off chance that you'll land on the same GPU that has your KV cache. So then they can just start decoding your data instead of recalculating, because they would like to generate more tokens for you. So how do you, and we call that the memory wall. How do you climb that memory wall? How do you pass it? Eventually, that's the key for modern cost-effective inferencing. You can try to throw more GPUs at it. You can try to complicate your orchestration environment. We do see multiple environments, multiple companies trying to solve that in different ways. For example, there's new models, linear models that are trying to create smaller KV caches, so to be more efficient. There are environments that are saying, hey, I already calculated the KV cache on one GPU, it's in my GPU memory, let's try to copy it. Or maybe I'm using my local environment for that. But how do you do that at scale in a cost-effective manner that doesn't strain your memory, doesn't strain your networking? So that's something that we're helping with some of these customers.
Yeah. It sounds like it's very much a big company issue so far with OpenAI, Anthropic, some of these bigger cluster users. But it's definitely something that's coming, right? With this agentic usage, right? We heard last time from Wonder, right? That this company, this in food delivery, where basically they were getting notifications from Azure in Northern Virginia saying, they had a location crunch and go find another location. So this sort of crunch is happening. And so can you talk a little bit about the economics of the KV cache process? It's like, how much are you saving with this?
Brilliant. So again,
or customers, how much are they saving?
So mileage will vary on use cases, because some use cases, for example, if I have a simple chatbot, just getting a few questions and answering, my context window is not that big, so maybe less valuable. Some use cases are very KV cache heavy. Example, code development, definitely, right?
Right.
Tax returns, everything with regulation, you have a lot of context and benefiting from KV cache. In some of the benchmarking and working with customers, some inference providers, some LLM providers, we saw that we can accelerate that by a factor of up to 4.2. That's a real number with multi-turn variation inferencing. 4.2x improvement. Just to explain what the magnitude of 4.2, it sounds like a small number, right? Imagine that you have 100 GPUs, and now these 100 GPUs emitting a certain amount of tokens. Imagine that now these 100 GPUs are working as if they're 420 GPUs, right? Just by adding this KV cache accelerated layer that we provide, 420 GPUs instead. That's a ridiculous amount of money. We're looking at some use cases where the saving amount would be millions of dollars per day for these inference providers.
Yeah.
Right. Um,
Yep, significant. So we're out of time on the talk. So let's go to questions. Is anyone? I'm just wondering. Anyone running Inference and running into the efficiency issue? Yeah. Do you want to maybe introduce yourself again and talk about the use case?
Yeah, for sure. So I'm working in AI inference optimizations at LinkedIn. We recently rolled out our own on-prem hosted hiring assistant for LinkedIn, and I was working on that. So we were facing a lot of memory-bound problems on the decoding side of the stages. And we felt that speculative decoding was something that really saved us a lot of like latency and increased our throughput by around like 4x. And these are like public numbers on the engineering blog, so feel free. Um, yeah, but just curious about like how you have seen speculative decoding evolve. And how can we like make it more efficient? Because right now, how it works is it just looks at the context that you have passed so far, but maybe that can be augmented with the token factories.
So it could be. I think it really depends on what our customers are doing eventually on our platform. I'm not familiar actually with any customer that's running speculative decoding, but as I mentioned, it really depends on the amount of KV cache that you're generating, and it's one more way to decrease the amount of KV cache eventually, right? Because you generate less of it, but eventually there's this paradox that the more you improve, the more you do, right? So even with that, imagine adding that acceleration layer on top of it and getting even further.
Yeah, thanks.
Any other questions around? Yeah, go ahead.
I do have one question. So, Rohit again. So, I lead the security at Equinix. So, one of the things that at least we are seeing with our customers, like a lot of them are opting for fractional GPUs. So, how does it help, like either solve the inferencing problem, or have you seen like your customers, are they like opting for fractional GPUs too? Like, because I
So
think that's what, especially from a data center or like cloud providers, I guess that's one of the things people are kind of figuring it on the back end. So yeah.
brilliant. I think it's a good question. We're actually working with a lot of the neo clouds, hyperscaler clouds, obviously neo clouds, and most often and not now sovereign clouds, where multi-tenancy in terms of clustering of GPUs and clustering of the storage is a major concern. We see some of them offering fractional GPUs. Realistically, what we're most often they're not seeing are actually clusters of GPU servers. So tenants are getting, because it's so expensive to get, they're just buying large numbers of GPUs for themselves. We see some of the neo clouds that are offering like maybe an on-demand environment. Eventually, a fractional GPU is also fractional in the memory of the GPU that you're getting. So these sort of solutions are actually able to take it even further. If you're getting a fractional GPU and you're bounded on the fractional memory, now suddenly being able to say, hey, I can spill my context over to unrelated to what my fractional memory can be, significantly accelerated. It's funny because I actually also heard another one of these GPU clouds that mentioned they're going to deploy they have their core environment, core cloud, and there's the edge environments, and obviously there's the edge aggregation, smaller data centers, still data center, but smaller data centers. And his take on this type of acceleration was you're actually safeguarding my investment, because if I'm putting somewhat slower GPUs, not the best of breed, not a lot of them, suddenly with this I can do much more. So I hope I answered your question.
You did. And yeah, I'll pick you up later. So yeah.
Brilliant, thanks.
And yeah,
Hi, I'm Tanu Singh. I'm a data scientist, and I have this question about the KV cache time limit. So, do you have any time limit on how long can the cache be stored?
I think that's the $1 million question, right? When we started, I have to say that we were engineering wise, we were very naive. Let's just extend the GPU memory and drop it, and then They're like, oh yeah, we need to delete it at some point because otherwise you're creating this token warehouse of sprawl of information. Eventually, what we're doing is we're working with customers that are looking at it, and what we're seeing is that different customers have different SLAs. So, for example, if we're working with an inference provider that says my SLA is 10 minutes for the data, and then afterwards everything is best effort. So eventually, if it spills over to our data environment, then you'd like to keep it as much as possible, but then there's sort of like least recently used algorithm that if it's not needed, and it can stay there as much as possible according to the customer SLA, and then it can be evicted.
Okay. Yeah.
But that's a really good question.
Thank you.
And one more thing I'll say is that obviously we see that seeping into enterprises. We're talking a lot about large inference providers, hyperscalers, neoclouds, but definitely next year we see is the year of the enterprises, right? The AI is becoming more and more dominant. And I mentioned this 420% improvement, 100 GPUs being, but even imagine an enterprise that's running 100 GPUs, getting 120 GPUs worth of, save them 20 GPUs. 20 GPUs is still hundreds of thousands of dollars, right? Just to.
I guess I have the mic. Hi, I'm Jane. I just really want to say I really appreciate this side of conversation. I heard data center mentions, and I'm from the data center side. I think what I'm just really interested in hearing all this because it helped me understand what you guys are trying to solve. But my question is, we've been trying to solve this to how to get you guys more power so you guys can build the clusters. How does it, is it really like location agnostic? Is it really latency agnostic when it comes to your application? That's probably a bigger question than you can.
Are you asking specifically about our product or in general?
Oh, just in general, right? But I feel like this is something that it just sparks a lot of questions.
Maybe what your customers want.
Yeah.
Wow.
What do your customers
Okay.
be helpful? Yeah.
I'll try
thank
tackling
you.
that. So customers want it for free and at zero power.
Yeah.
But to be realistic, yeah. To be realistic, by the way, one of our investors is Al Gore with Generation AM, which is has a very green mentality, right? And in the past, by the way, green mentality meant let's have a checkbox. We're green, boom. Now I'm sad but happy to say green mentality is equates to dollars. So the number one requirement we see from our customers is, can you be more cost effective, more power efficient? Because now if my power utilization doubles, quadruples every several years, and if I can get that power to begin with, by the way, because we see our customers also being very creative about how they generate the power. So a lot of these neoclouds are located in environments where they can generate the power. Power plants, nuclear power plants, renewable energy, hydro. And then it's like, let's use it efficiently as possible. So one thing which I would mention is along these lines is the more dense your solution is, the less power, the less switches, networking cable, or rack footprint, cooling, heating, the better. So that's number one out of like a list of 100 requirements. The rest of the 99, yeah.
Question, yeah. Oh, sorry, who wasn't?
Yeah, so mine is just sorry. Yeah, this reminds me of some of the work I did earlier on instruction level parallelism back in the early 90s, where a lot of code extraction, code optimization, and L1 cache. Do you see more at the coarse grain level now, like L1, L2, L3? So not at the KV cache, at the instruction level optimization, but more at a cluster of GPUs and doing coarse grain, similar to like how the traditional computing was done. Yeah.
Really good topic. We're actually working with NVIDIA on their Dynamo project. And one of the things that I mentioned is that we do see other methods that are trying to solve this KV cache environment challenge. And yes, we definitely see that there's multiple tiers within the server itself that are trying to allocate for it. But it's nice. And there's also some proprietary hardware devices that are meant to accelerate KV cache within a server. The problem and scale is somewhat different. It's
But eventually it will morph into those kinds of problems.
exactly.
So I
Yes.
have two-part question. So first is we have seen the cost of the overall the GPU, all of this hardware is getting lower, right? Over the time, and hopefully gonna. What do you see actually in the near future the the cost of overall from the GPU and including the memories are also gonna be decreased significantly. The second part is in the enterprise environment, usually we actually really hope to get the cost upfront, like very predictable. So meaning sometimes it might not be necessary it's all the trade-offs, right? So about the SLAs, the latency, all but in the end of the day, we also want to balance the cost. So if we can get the overall the cost, the predicted cost, then we can also optimize what things we can do, and it's just like we talk about the PG&E, we can also optimize certain workflows so that can be, if it's not prioritized, it's not urgent, can be prioritized to do it better. So to help optimize the cost in general.
Okay, I think I remember the first part. I'll start answering that. What do we see with GPU costs and memories, and it's actually worsening. So as you know, there's a shortage in flash devices worldwide, and that relates to memory NAND, HBMs. HBM costs are increasing significantly. Flash devices, NVMEs, SSDs. So it's going to get worse before it's going to get better. There's a lot of it's funny, I was talking about with somebody today. During COVID, everybody bought a certain amount of something, and then everybody bought it again. And why? Because. So that's kind of like the rush of everybody's buying NAND today. So there is I would say that in that way, if you can use anything, it gives you a lot of flexibility. I will point about ourselves a bit. It's not a sales pitch, but we mentioned, imagine that because we created a software-defined environment, we can use multiple types of NAND. So whatever's available, we'll use. More than that, we created an environment that can fold in and run all of that within your GPU servers without the need for external NAND. So there's a lot. The more flexible you'll be, the more you'll be able to provide during that time of shortage. And obviously you want to do, it will be harder to get GPUs also. So the more you can get out of your GPUs, obviously the better. To the second part of your question around predictability, I think in enterprise, that's the key, because we see a lot of enterprise AI workloads that are now, and I think we talked about it also before, that are pointed toward the organization still. And a lot of AI use cases are not external pointed. They're still being used internally, internal chatbots, AB environment. Next year, we think that we'll see more of it going outbound, especially with sovereign clouds that are advancing technology and research for their sovereign environments. The ability to be predictable is going to be more important. So for that, taking that shortage and taking this SLA and predictability requirement, what we're saying is if we can provide an environment, or if customers can benefit from an environment where you have a set amount of known flops on your GPUs, known memory, known KV cache capacity, that you can, and the knob that you need to turn to meet your SLA is just this augmented memory environment, which is a fairly cheap knob compared to buying 100 or 1,000 more GPUs. That's definitely an advantageous way to go.
We are out of time. Shimon, thank you very much for joining us and for supporting us with that. Yep. Thank you.